Okay, so we're getting towards the end of our first unit. And one of the last topics we need to talk about is Dalton's atomic theory, or the characteristics of atoms. Dalton lived in 1800. He was born in 1744, so before our American Revolution. And he was making most of his atomic theory over 200 years ago. So some of what he thought then is not exactly what we think today, but he is considered the founder of modern chemistry. So many of his ideas are the basis that we built our understanding of chemistry today. So we still study his ideas and give credit to him for coming up with these foundational ideas. First thing that he believed, and what we still know today, is that atoms cannot be broken into smaller pieces. Now, with the exception of a nuclear reaction or a nuclear reaction in an atomic bomb, this is still true today. We cannot break atoms, and it can't be broken. Dalton imagined that atoms were like tiny marbles or rigid spheres that were impossible to break. Now, this is not what we think today. And when he went to school, it kind of made sense. You think of something like your desk. It's hard. It's solid. So he imagined gazillions and billions and little tiny marbles packed tightly together that made things up. And then some of the air, the little marbles were just sort of floating around farther apart. This is not what we think today. Today we know that atom is mostly empty space, has a very small nucleus of protons and neutrons, and then swirling around that is a cloud of electrons. And that cloud of the electrons are infinitesimally small. They don't have any mass, basically. We can think of this as little particles of energy. And they're swirling around the nucleus in that empty space. Now, the next thing that Adam thought is that in any element, all the atoms are exactly alike. And this is still true. This is what we think today. We don't believe that there are different kinds of uranium atoms, or there's different kinds of oxygen atoms. Oxygen atoms are all the same, all around the world, all over the universe. And this idea explained why an element always had the same properties. So no matter where we find something like iron, it always has the same properties. It's always magnetic, it's always hard, it always reacts with oxygen to make rust. So for example, all gold atoms are alike. Whether you find it in the United States, Canada, Europe, Asia, Africa, gold is just gold. Now, since all the atoms of any particular element were exactly the same, then Dalton also believed that atoms of different elements were different. So, for example, gold atoms are not like iron atoms. What he believed, and we still believe today, is that gold atoms were different than iron atoms, and that's why gold had its properties and iron had its properties. Oxygen atoms are different than iron atoms or gold atoms. So each element had its own kind of atom, and that's why each element had its own unique properties. So this idea explained why different elements have unique sets of properties. So for example, iron, as we said, has its properties, and gold is shiny and it's malleable. You can bend it into shape easily. It has its own unique set of properties, and those properties are different, for example, than iron. And he also believed, and we've been learning about this, elements are one of the pure substances, and the other kind of pure substance was a compound. So Dalton also believed that atoms of two or more elements could combine to form a compound, and that compounds could be broken down into elements. So Dalton concluded that compounds had to be made of atoms as well. Earlier in the unit, I showed you that little video that man was breaking water, H2O, which is a compound, down into the elements of hydrogen and oxygen. And that we said was a chemical change. It was a chemical reaction to break the compound down. Okay. Dalton believed that atoms of each element had their own unique mass. This is also what we think today. The masses of the elements are listed on the periodic table, and we're going to be learning more about that as the year goes on. Scientists of Dalton's day over 200 years ago obviously could not measure the mass of individual atoms. And we really can't do that today. What we do is we measure a big group of atoms and we divide by the number of atoms and find the mass of one that way. So Dalton also believed the masses of the elements in a compound are always in a constant ratio. And as we said, the elements are always in a constant ratio. So for example, there's always two hydrogens and one oxygen and water. So for example, water is a compound made up of two hydrogens and one oxygen. In any pure sample of water, the ratio of the mass of hydrogen and oxygen is always exactly the same. The ratio 2 hydrogens to 1 oxygen is the formula. So since the ratio is the formula, if you take the masses of the atoms in the formula, the mass is always going to be in a ratio. Now, you don't need to be able to do this, but I just wanted to explain what this means. So here's the formula, H2O. The mass of 2 hydrogens is 1 plus 1, which is 2. And it tells us here on the periodic table, the mass of hydrogen is 1. It's a little hard to see, it says 1.00. Okay. And then the mass of oxygen is 15. We're just going to round this up to 16. So we only have 1 oxygen, so its mass is 16. And the 2 hydrogens, their masses are 2. 1 plus 1 because there's 2 of them. So the ratio of the mass is always 2 to 16 in every water molecule, always, no exceptions. Okay. Now, Dalton also realized that there was something holding these compounds together. And the force that holds the compounds together is called a chemical bond. When 2 or more atoms are joined together, the new substance is called a compound or a molecule. Okay, so this little red line right here, this is the chemical bond. Okay, these 2 little atoms in the picture down here are the hydrogens. So the formula is H2O. There's 1 oxygen. Right here is a chemical bond. I highlighted in red. Over here is another one. I did not highlight this one. Okay. And this represents the compound water, H2O, always in this constant ratio, 2 hydrogens to 1 oxygen. And we figure out the ratio of the masses. Each hydrogen has a mass of 1, so there's 2 of them. Oxygen has a mass of 16, and there's only 1 of them. So the ratio of the masses is 2 to 16. Okay, today's lesson was kind of short, so I hope you're having a good afternoon, and we'll see you next time.